Alright, good people, welcome to section 2.7, Radical Equations. So the one new principle that we have is if a equals b, then a to the n equals b to the n. And that's for most values of n. Warning, check for false solutions, and the strategy is going to be to isolate the variable. What this really means is that you can take the, say, square of both sides of an equation. You're allowed to do this, but just make sure that you check for a false solution. They can introduce false solutions, so you need to check everything that you get. So for example, here, the square and the square root cancel out. Now this is different from when you needed absolute values because you're undoing the square root as opposed to undoing the square. You get an answer of x equals 25 over 2. So let's check to see that it works. The 2's cancel, and you take the square root of 25, and that's not equal to the negative 5. So there are no real solutions here. There might be some imaginary solutions, but we're not going to worry about that in this section. In this next example, we're going to see what it means to isolate the radical as a strategy. So here, we're going to get the radical over to the right-hand side. We're going to add the square root of x plus 5, and we're going to subtract 1. And so what that gives us is the radical all by itself on the right-hand side, and then x minus 1 on the left-hand side. To undo the radical, you can square both sides, which is perfectly legal, but you have to make sure that you check all your solutions, because you could be introducing new solutions. The radical cancels out, you're left with just x plus 5, and then when you square x minus 1, you get x squared minus 2x plus 1. And then solving the resulting equation for 0, combining all the terms, you get x squared minus 3x minus 4 is equal to 0. Factoring, because of course you have to find out what numbers multiply up to negative 4 and add up to negative 3. That's, of course, the number is negative 4 times positive 1. Negative 4 times positive 1 is negative 4, and then negative 4 plus 1 is negative 3. So the factors are x minus 4 and x plus 1 equals 0. Splitting up that equation into the two separate linear equations, you get x minus 4 equals 0, or x plus 1 equals 0. So therefore, you can say that x equals 4, or x equals negative 1. Now you have to check both of these solutions. Maybe they're both valid solutions, or maybe one of them isn't, or maybe neither of them isn't, but you have to check. So putting 4 into the original equation, you get 4 minus the square root of 4 plus 5. Simplifying the radical, 4 plus 5 is 9. And so, yeah, 4 minus 3 is, in fact, equal to 1. Again, checking negative 1, you get 4 minus the square root of negative 1 plus 5. Is that really equal to 1? Let's find out. We get 4 minus the square root of 4. And maybe that's equal to 1. And you see 4 minus 2 is definitely not equal to 1. So therefore, there's x equals negative 1 is not the solution, and x equals 4 is. Again, this is a technique that you introduce in order to get rid of cancel out radicals, but it just introduces too many solutions sometimes. Cancel out this radical by taking both sides to the power of 4. You get 3x minus 1 equals 2 to the 4th. 2 to the 4th is 16. 2 times 2 times 2 times 2. There you go. 3x equals 17. And x equals 17 over 3. we have to check our one solution. Substituting, we get, after the 3's cancel, 16. Is the cube root of, the fourth root of 16 equal to 2? Yes. So therefore, x equals 17 over 3 is the one solution that we have. So here we get an equation that if you simply square it, you're not going to completely get rid of the radicals the first time around. You're going to have to square it twice. Let me show you what I mean. So if you're squaring this, you could think of like a is equal to the square root of x and b is equal to the square root of x minus 5. So then really what we have is a minus b squared is equal to 1. Remembering the formula, we can translate that into a squared minus 2ab plus b squared is equal to 1. Now the a squared term is going to be the square root of x squared is just x. And then 2 times a is 2 times the square root of x times b, which is the square root of x minus 5. B squared is going to be just x minus 5 because the square roots cancel out. And that's all equal to 1. Now we have to isolate the radical because we're about to do this again. We need to add 5 to both sides, subtract x, get all those other terms to the other side. So we're adding 5 and subtracting eventually 2x. That leaves us with negative 2, and I'm just going to combine the two radicals together to get the square root of x times x minus 5. And that's all equal to 6 minus 2x. Again, attempting to isolate the radical, you can divide both sides by negative 2. And when you do that, you have to divide all the terms on both sides by negative 2. And you get the square root of x times x minus 5. Negative 3 plus x. How do we get rid of the radical? You got to square it. I'm just going to rearrange x, negative 3 and x, so that it looks a bit more familiar. And I'm going to distribute those terms, so we get x squared minus 5x is equal to x squared minus 6x plus 9. Combining all the terms into one side, and maybe it would have been easier the other way around, but I like getting rid of the subtraction. So we're left with negative 1x plus 9, adding x to both sides, you get x equals 9. That might be the solution, but we have to check it first. So the question is the square root of 9 minus the square root of 9 minus 5, is that going to equal 1? By the way, while I finish the rest of this check, I'll just let you know that the audio check for today is, fun fact, the Friends of the Wissahickon was founded in 1924. Friends of the Wissahickon have been around since 1924. Isn't that great? By the way, that solution works. It checks out. Alright, next problem. Well, I'm just going to square both sides. You could try isolating the variables, but it's not going to make it that much easier. We'll just square it here and see what happens. So it cancels out the first radical. That's great. But now we got to square this binomial. So we get 1 squared is 1, and the square root of x plus 4 is squared is going to be just x plus 4. But then we have to multiply the a term and the b term, and then multiply them by 2. So we get 2 root x plus 4. Isolating the radical, we get so we have to move the 4, the x, and the 1 over to the left-hand side. We subtract x from both sides, and also a total of negative 5. Leaving us with 2x minus 4 is equal to 2 root x plus 4. Attempting to isolate the radical further, we divide all the terms on both sides by 2, and now we have x minus 2, which is equal to the square root of x plus 4. Great. How do we get rid of the square root? We square both sides. X minus 2 squared, that's going to be x squared minus 4x plus 4. I'll fix that minus 4 in a second. Equals x plus 4. Subtracting 4 from both sides, subtracting x from both sides, we get x squared minus 5x equals 0. Solving this equation, it's just easiest to factor out the GCF, which is just x. You get x minus 5, which is equal to 0. And then you can split it up into two different equations. You can say x is equal to 0, or x minus 5 is equal to 0. And if x minus 5 is equal to 0, then you could say that x is equal to 5. Let's check these solutions. Maybe one of them will work, maybe neither of them will work, maybe both will work. Let's find out. Plugging 0 into the original equation, you get the square root of 3 times 0 plus 1 is equal to 1 plus the square root of 0 plus 4. So are they really equal to each other? Is 1 really equal to 1 plus the square root of 4, which is 2? No. So 0 is not going to be a solution. Let's check to see if 5 is. That would be the square root of 3 times 5 plus 1. Is that equal to 1 plus square root of 5 plus 4? Simplifying, we get the square root of 16, which is 4. Is that equal to 1 plus the square root of 9, which is 3? Yes, it is. So x equals 5 is our solution. We've got one more problem here, and it's going to be kind of like one of those problem-solving, rearrange the formula. We have to solve for m. So, let's square both sides to get rid of the radical. You get p squared equals m squared minus 1 over m squared. And I think I'm just going to split up this fraction into two fractions. M squared over m squared equals 1 over m squared. There might be easier ways to do this, but I think you get down to one place where m is, and that makes it a lot easier. So now I need to get the 1 over m squared term by itself. I'll subtract 1 from both sides to leave me with negative 1 over m squared on the right hand side. I'll multiply all the terms on both sides by negative 1, so the p squared becomes negative, the minus 1 becomes positive. and then I'll take the reciprocal of both sides. As a last step, I'm going to take the square root of both sides, and I get the square root of 1 over 1 minus p squared is equal to m. There it is. I'd like you to begin assignment 2G. That means copy down the problem list into your composition books and do the first problem. I'll see you in class.